Hello, everyone. In this chapter, we're going to talk about artificial intelligence, commonly known as AI. So, what is artificial intelligence? It's a branch of computer science that deals with the simulation of intelligent human behavior by a computer. Essentially, it's about replicating the cognitive functions of the human brain in a machine. Imagine computers that can think, learn, and make decisions similarly to humans. That's the core idea behind AI. Let's dive into the history of AI. We start with the dormant period, from 1943 to 1956. The journey of artificial intelligence began in 1943 with the introduction of the concept of the neuron by Warren McCulloch and Walter Pitts. This concept laid the foundational principles for neural networks, which are essential for AI development. In 1946, the creation of ENIAC, the first programmable electronic digital computer, showcased the potential of machines to perform complex calculations. Then, in 1947, Alan Turing introduced the concept of artificial intelligence, envisioning machines capable of performing tasks requiring human intelligence. Turing's work laid the groundwork for thinking about machines as intelligent entities capable of reasoning and problem solving. Moving on to the Dawn period, from 1956 to 1986. In 1956, the Dartmouth Summer Research Project on Artificial Intelligence marked a significant milestone. Considered the official birth of AI as a field, this event brought together leading researchers who aimed to explore the potential of machines to simulate human intelligence. In 1964, Joseph Weizenbaum created ELIZA, one of the first chatterbots, which demonstrated early capabilities in natural language processing. Despite these advancements, progress was slow, and AI research faced numerous challenges, leading to what some call the AI winter. During this time, funding and interest in AI research declined due to unmet expectations and limited computational power. Then we have the development period, from 1986 to 2011. The AI field experienced a resurgence in 1986 with the introduction of the backpropagation algorithm, which significantly improved the training of neural networks. This period saw steady progress in AI applications. One notable achievement was IBM's Deep Blue, defeating the world chess champion in 1999. This event was groundbreaking because it showed that machines could compete with and even surpass human intelligence in specific tasks. AI continued to develop incrementally, with advancements in machine learning and data processing capabilities setting the stage for future breakthroughs. Finally, we arrive at the leap period, from 2011 to the present. The leap period began with IBM Watson's victory, in the popular quiz show, Jeopardy! In 2011. This victory highlighted AI's ability to process and understand natural language at a high level. In 2012, Google's experiments with self-driving cars, and the success of the deep learning model AlexNet in the ImageNet large-scale visual recognition challenge showcased AI's potential in practical applications. The pace of AI advancements accelerated rapidly, with Google's AlphaGo defeating the world champion Go player in 2016. In the same year, AI systems like Libratus and DeepStack outperformed professional poker players, demonstrating AI's growing prowess in complex decision-making and strategic thinking. These breakthroughs highlighted AI's ability to handle tasks involving intuition, strategy, and real-time decision-making. This journey from the early conceptualizations in the 1940s to the sophisticated AI systems of today highlights the dynamic and rapidly evolving nature of artificial intelligence. The progress made during these periods continues to shape the future of AI, driving innovation across various industries. AI is now a crucial component in fields ranging from healthcare and finance to transportation and entertainment. Before we move on to an example of AI in action, let's talk about the different types of AI. There are three main categories: narrow AI, general AI, and strong AI. Narrow AI, also known as weak AI, is designed to perform a narrow task, such as facial recognition or internet searches. It has superior performance to a human in one specific task. Examples of narrow AI include virtual assistants like Siri and Alexa, as well as smart home devices. However, narrow AI cannot possess, understand, or learn tasks beyond its specific programming. General AI, sometimes referred to as strong AI, is a machine with the ability to perform any intellectual task that a human can do. It has similar performance to a human in many tasks. General AI is still not well developed and remains largely theoretical. It may raise ethical problems and present risks such as existential and security risks. Strong AI, also known as superintelligence, surpasses human intelligence across the board. It has superior performance to a human in many tasks. Strong AI does not yet exist and remains a topic of speculation and research. Its potential existence in the future could pose significant risks and challenges, including ethical and existential issues. Now, let's look at an example of AI in action. Consider a smart home device. When a smart device is asked a question by a human, the human voice is converted into a binary system, and the smart device processes the human command and outputs a verbal response. For instance, when you say, "Hey Alexa, how is the weather today?" Alexa responds with, "It will be 34 degrees Celsius at noon." This process involves voice recognition, natural language processing, and real-time data retrieval. Smart home devices illustrate how AI can integrate seamlessly into our daily lives, making tasks more convenient and efficient. There are two main types of AI systems: expert systems and machine learning systems. Expert systems are designed to mimic human decision-making. They are used to solve problems or answer questions requiring a human expert. These systems use knowledge and inference to provide conclusions and suggested actions with percentage probabilities of accuracy. They interact with users through dialog boxes or command prompts, often providing only yes, no answers or multiple choices. The main processing element of an expert system acts like a search engine, gathering information from the user by asking a series of questions. These systems follow logical thinking, using inference rules such as if statements and and conditions to draw conclusions from a repository of facts stored in a knowledge base. For example, in a medical expert system, the input might involve asking a series of questions about a patient's illness. The user answers multiple choice questions or provides yes, no responses. The expert system then compares and matches the symptoms with its knowledge base, suggests the probability of the patient's illness, suggests possible solutions, and provides reasons for its diagnosis to validate the suggestions. This application of expert systems can significantly enhance the accuracy and efficiency of medical diagnoses and treatments. Let's consider another example: financial expert systems. These systems help in investment planning and stock trading. They analyze large volumes of financial data, including market trends, historical data, and economic indicators. By using this information, they provide investment advice, predict stock movements, and identify potential risks. For instance, a financial expert system might advise an investor to buy certain stocks based on predicted market growth, or to sell stocks that are expected to decline in value. This can greatly aid investors in making informed decisions and optimizing their portfolios. Expert systems are also widely used in customer support. For example, an help desk expert system can assist users in troubleshooting computer issues. When a user reports a problem, the system asks a series of diagnostic questions to narrow down the potential causes. Based on the user's responses, the system can provide step-by-step solutions or escalate the issue to a human technician if needed. This helps in resolving technical issues quickly and efficiently, reducing downtime and improving user satisfaction. In agriculture, expert systems are used for crop management. These systems analyze data such as soil quality, weather conditions, and crop health to provide farmers with recommendations on irrigation, fertilization, and pest control. For example, an expert system might suggest the best time to water crops based on weather forecasts, or recommend specific fertilizers to enhance soil nutrients. This helps farmers optimize crop yields and reduce costs. Machine learning systems, on the other hand, are algorithms that are trained to learn from past experiences and examples. These systems make predictions and take decisions based on previous scenarios, managing and analyzing large volumes of complex data. An example of a machine learning system is a recommendation system. Based on a user's browsing history, the system recommends and predicts items that the user may be interested in. For instance, platforms like Netflix and Amazon use machine learning algorithms to suggest movies or products based on users' past behavior. This personalization improves user experience and engagement, demonstrating the practical benefits of machine learning in everyday applications. Let's compare AI and machine learning. The goal of AI is to develop machines with the ability to think similarly to humans. while the goal of machine learning is to make machines that learn through data acquisition to solve problems. AI uses rule-based systems, logic, knowledge representation, and other methods in addition to machine learning. In contrast, machine learning relies on data and statistical techniques to learn from experience. While AI encompasses a broader range of technologies, machine learning is a subset of AI focused specifically on enabling machines to learn from data. Today, we've covered a lot of ground in our exploration of artificial intelligence. We began with an introduction to what AI is and its ability to simulate human cognitive functions in machines. We then traced the history of AI, from the early conceptualizations in the 1940s, through its various developmental periods up to the present day. We explored the types of AI systems, focusing on expert systems and machine learning. We examined how expert systems mimic human decision-making and how machine learning systems learn from past experiences to make predictions and decisions. We also highlighted the relationship between AI, expert systems, and machine learning. As we move forward, I encourage you to think about specific AI applications that interest you. Consider how the principles and technologies we've discussed today apply to those applications, and weigh the pros and cons. AI is a rapidly evolving field with immense potential, and understanding its foundational principles is crucial for navigating its future developments. That's it for today's lesson. Thank you for your attention. See you.